After studying this module, you shall be able to know the non-parametric test, chi-square test of contingencies, learn about the basic concepts and assumptions involved in its applications, understand the numerical application of the test, and know about the IBM SPSS commands to apply the test. The chi-square test for independence of two variables is a test which uses a cross-classification table to examine the nature of the relationship between these variables. These tables are sometimes referred to as contingency tables. These tables show the manner in which two variables are either related or are not related to each other. The test for independence examines whether the observed pattern between the variables in the table is strong enough to show that the two variables are dependent on each other or not. While the chi-square statistic and distribution are used in this test, the test is quite distinct from the test of goodness of fit. The goodness of fit test examines only one variable, while the test of independence is concerned with the relationship between two variables. Like the goodness of fit test, the chi-square test of independence is very general and can be used with variables measured on any type of scale: nominal, ordinal, interval or ratio. The only limitation on the use of this test is that the sample sizes must be sufficiently large to ensure that the expected number of cases in each category is 5 or more. This rule can be modified somewhat, but as with all approximations, larger sample size are preferable to smaller sample sizes. There are no other limitations on the use of the test, and the chi-square statistic can be used to test any contingency or cross-classification table for independence of the two variables. The chi-square test for independence is conducted by assuming that there is no relationship between the two variables being examined. The alternative hypothesis is that there is some relationship between the variables. Let us take an example. A marketing research organization is interested in knowing if it is the physical attributes or technical qualities that make a difference in the sales targets of a particular automobile. The customers were asked to rate the choices in terms of color and mileage for the automobile. The chi-square test is a useful method to compare the experimentally obtained data with the theoretically expected on some hypothesis. We have learned this in the earlier module. The present module discusses another useful application of the chi-square method: the chi-square test of independence in contingency table. A contingency table is the arrangement of the data in the form of a double entry or two-way table in which the observations by a group of varying degrees of two characteristics is represented. The figure 1 shows a contingency table with two groups and three categories of variable measured. Each cell shows the frequency observed for it. The totals of rows and columns is shown as R and C. The sum of all the frequencies is N. The chi-square test of contingencies. The concept of the test. When the research data is in nominal or ordinal scales of measurement, the chi-square is a suitable non-parametric measure to identify the significance of differences between two independent groups. When there are two groups that differ on a chosen variable and the observations are made in terms of frequencies in different categories, the relative frequencies can be compared. between the categories among the group. The chi-square test facilitates the comparison among the groups on the chosen variable between the different categories. The hypothesis focuses on testing if the differences in the proportion of frequencies exceed the expected random deviations of proportionality. The chi-square is given as 1 minus n minus e whole square upon e, where n is the observed frequency in the ith and the jth column. Eij is the expected frequency in the jth column if the null hypothesis is true. Application of the test. The chi-square test of contingencies is suitable when the variables are measured in nominal or ordinal level. The data consists of frequencies in discrete categories. The observations are independent of each other, and the hypothesis to be tested is that the two groups differ with respect to some characteristic, with respect to the relative frequency with which group members fall in several categories. So, if a researcher is interested in studying the relationship between two categorical variables, then the chi-square is a suitable test. The test studies and compares the frequencies of one obtains from these categories to those that are expected in the categories by chance. The deviations between the expected and the observed frequencies are studied. The deviations are compared with distribution with known properties and inferences are drawn. Let us look at an example. Suppose that 125 children are shown 3 television commercials for breakfast cereal and are asked to pick which one they like the best. The results are shown in the table. You would like to know if the choice of favorite commercial was related to whether the child was a boy or a girl, or if these two variables are independent. The totals in the margin will allow you to understand the overall probability of liking commercial A, B or C regardless of gender, and being either a boy or a girl regardless of favorite commercial. If the two variables are independent, then you should be able to use these probabilities to predict approximately how many children should be in each cell. If the actual count is very different from the count that you would expect if the probabilities are independent, the two variables must be related. Of course, there is a diagrammatic representation and the chi-square has been calculated. Consider the upper right cell of the table. The overall probability of a child in the sample being a boy is 75 divided by 125, that is equal to 0.6. The overall probability of liking a commercial A is 42 divided by 125 equal to 0.336. The multiplication rule states that the probability of both of two independent events occurring is the product of their two probabilities. Therefore, the probability of a child both being a boy and liking a commercial A is 0.6 into 0.336, that is 2.02. The expected number of children in this cell then is 0.202 into 125, that is 25.2. There is a faster way of computing the expected count for each cell. Multiply the row total by the column total and divide by n. The expected count for the first cell is therefore 75 into 42 divided by 125, which comes to 25.2. If you perform this operation for each cell, you get the expected counts in parentheses shown in table 2. Note that the expected counts properly add up to the row and column totals. You are now ready for the formula of chi-square, which compares each cell's actual count to its expected count. Chi-square is equal to sum of observed frequency minus the expected frequencies squared divided by the expected frequency. On application of the formula, one finds that the chi-square is 9.098. The larger the chi-square, the more likely that the variables are related to each other. Note that the cells that contribute the most to the resulting statistic are those in which the expected count is very different from the actual count. Chi-square has the probability distribution, the critical values for which are listed in table 4 in statistics table. As with the t-distribution, chi-square has a degrees of freedom parameter and the formula for which is number of rows minus 1 into number of columns minus 1, which in the case of this example turns out to be 2 minus 1 into 3 minus 1, that is 1 into 2 equal to 2. The statistics table of chi-square gives the value of 9.097 with 2 degrees of freedom, falls between the commonly used significance level of 0.05 and 0.01. If you had specified an alpha of 0.05 for the test, you could therefore reject the null hypothesis that gender and favorite commercial are independent at alpha equal to 0.01. However, you could not reject the null hypothesis in this case. So, the chi-square test does not allow you to conclude anything more specific than that there is some relationship in your sample between gender and commercial light at alpha equal to 0.05. Examining the observed versus expected counts in each cell might give you a clue as to the nature of the relationship and which levels of the variables are involved. For example, commercial B appears to have been liked more by girls than boys, but chi-square tests only the very general null hypothesis that the two variables are independent. Sometimes a chi-square test of homogeneity of populations is used. It is very similar to the test for independence. In fact, the mechanics of these tests are identical. The real difference is in the design of the study and the sampling method. The assumptions for the test. The chi-square test does not rely on assumptions like most of the parametric tests. As in the data are in qualitative scales and thus normality in data is not expected. However, still there are two important assumptions to be met. Chi-square contingency test cannot be implemented on repeated measure design. Each cell of the contingency table has observations independent of each other. In other words, each person, item or entity contributes to just one cell of the contingency table. The expected frequency in each cell of the contingency table should be greater than 5. A smaller value would lead to loss of statistical power and the real statistical effect may be lost. Steps in chi-square test of contingency. The steps involved in conducting the chi-square test of contingency for two independent samples can be listed like this. Take the collected data and form a contingency table out of it. Refer to figure 1. The row into column table depicts column as the groups and R as the categorical variable. Also, the totals of the rows and columns have to be calculated. Once the observed frequencies have been entered, the expected frequencies for each cell may be found by finding the product of the corresponding rows and columns total and dividing it by the grand sum n. Like given in equation 1, expected frequency for any cell is equal to row and column total divided by the grand total. Determine the observed chi-square and its significance by referring to the table of critical values of chi-square distribution. This is done by locating the degrees of freedom, which in case of chi-square is df is equal to r minus 1 into c minus 1, where r is the number of rows and c is the number of columns. One must know that the sampling distribution of chi-square changes with each value of df. One rejects the null hypothesis if the probability given in the table is equal to or smaller than the alpha and accepts the alternative hypothesis. Let us look into a numerical application of chi-square. A soft drink company wishes to study if the males and females differ in their choice of the 3 flavors manufactured by them. The data was collected and is represented in the table below. Have a look at the first column, which gives the 3 flavors in the 3 rows: cola, orange and lemon. The column number 2 and 3 talks about the distribution for the 3 flavors as preferred by males and females. The expected frequencies can be calculated by the formula given in the equation above, and for each of the cells, 6 cells, the expected frequencies have been calculated. Of course, the row totals and the column totals are also there, and the grand total n is also calculated. As the data has observed frequencies in the form of contingency table, the expected frequency were calculated by using the equation 1. The expected frequencies are shown in red color in each cell. Using the formula of chi-square, the chi-square value is calculated to 10.67. So, the chi-square calculated as 10.67 with a degree of freedom of 2, the table of chi-square distribution shows that chi-square is equal to 10.67 is significant beyond the alpha of 0.01. Thus, one rejects the null hypothesis of no difference between the groups at alpha equal to 0.01. Applications of chi-square to a 2 into 2 contingency table. The special case of chi-square is when number of rows and columns are equal. In such cases, the calculation of expected frequencies for each cell can be avoided by application of the following formula of chi-square. Chi-square is equal to n multiplied with AD minus BC minus n upon 2 whole square divided by A plus B into C plus D into A plus C into B plus D, where A, B, C and D are frequencies in the cell. df for 2 into 2 contingency table on application of df formula will be 1. This formula is relatively easier to apply in a 2 into 2 contingency table by reducing the number of mathematical operations involved. Also, the equation takes care of discontinuity in the data by applying a simple correction that improves the chi-square distribution. A researcher wants to study the effect of tea consumption on sleep among the adults. The subjects were asked if they consumed tea just an hour before going to sleep and if they had a sound sleep or not. The obtained data is given in the form of a 2 into 2 contingency table. Have a look at the table and then apply the formula. Of course, each cell has been marked. A, B, C, D and the frequencies are given. The column and row totals have also been calculated. Once we apply the formula for chi-square, we find that the chi-square turns out to be 7.42. The calculated chi-square was referred to the table probability of occurrence when the null hypothesis is true. The critical value is found to be 6.64 at alpha equal to 0.01. As the observed value is more than the table value, we reject the null hypothesis of no difference. Yates continuity correction. In a 2 into 2 contingency table, When the entries to the cells are very small, that is less than 5, then chi-square produces values that are very small and prone to type 1 errors. To check this, Yates continuity correction may be applied, which suggests subtracting 0.5 from the absolute deviation before squaring them. The aim is to lower the value of chi-square to check the type 1 error. However, this practice is not much popular in the current scenario. The IBM SPSS application. Let us follow the example discussed under section 4.1 for understanding the basic commands to conduct the chi-square test using IBM SPSS. A soft drink company wishes to study if the males and females differ in their choices of the 3 flavors manufactured by them. The data was collected from 42 males and 53 females, and their preferences for the flavors of the soft drinks brand were recorded. The chi-square test of contingency was applied to know if the deviations were significant. The commands are as follows. The data for chi-square can be entered for IBM SPSS either as the raw scores or as the frequencies for the categories and groups. Analyze, descriptive statistics, cross tabs. Select variable flavors, drag to rows, enter. Select variable gender, drag to columns, enter. Click statistics, chi-square, continue. Summary. The chi-square test is a useful method to compare the experimentally obtained data with the theoretically expected on some hypothesis. A contingency table is an arrangement of the data in the form of a double entry or two-way table in which the observations by a group of varying degrees of 2 characteristics is represented. The chi-square facilitates the comparison among the groups on the chosen variable between the different categories. The hypothesis focuses on testing if the differences in the proportion or frequencies exceeds the expected random deviations of proportionality. If a researcher is interested in studying the relationship between 2 categorical variables, then chi-square is a suitable test. The test studies and compares the frequencies one obtains in these categories to those that are expected in the categories by chance. Assumptions of the test are also discussed. Although the test is a non-parametric test, but still there are minor assumptions that need to be fulfilled. The chi-square can be applied to contingency table, and also the simpler versions of chi-square are there for a 2×2 contingency table. The Yates continuity correction is also discussed in the test. The IBM SPSS commands to carry out the chi-square test are also given in the module.